Right, welcome to the last lecture for dynamics. Okay, specifically, it's on the topic of friction. Now, friction is something that you come across every day, and this is definitely not the first time you have heard of it. Okay, but what exactly is friction? Right, basically, it's a contact force. Okay, that opposes or tends to oppose motion, okay, between surfaces in contact. Now this means that, okay, if I have no contact, rather let's say between two objects, if there are no contacts between them, there won't be any friction. And why is there friction? Let's say when you rub two objects together. Now, so for example, if I were to zoom in to each of their surface, right, you will realize that in the real world, they are not as smooth as what you see with your naked eyes. Right? They are actually made out of jagged edges. So for example, right, this is the block on top. And what happens if I move it from left to right across? Okay, you will realize that each of the jagged edges, right, will push against the other jagged edges as well. Okay, this will create a resistant force, right, whereby let's say I'm moving this object from left to right. Okay, the other block will exert a force towards the left to oppose its motion. So this is friction. Okay, so it happens due to the irregularities of the surface. Right, friction is essential in our daily lives, right? Be it positive or negative, right? Because we need friction for us to move, but also let's say for cars, right, or swimmers, they get slowed down by friction as well. Okay, so for example, we are able to walk, right, due to friction. Okay, so that's one positive effect. So again, if you recall from the Newton's third law example that I gave in class, for us to be able to move forward, right, the shoe will have to slide on the floor backwards, right? And in turns, the uh, okay, so because the shoe slides on the floor, exerting on the ground, exert on the ground, right, to the left, the floor will exert in return a force that is opposite in direction, okay, forward. That's what causes us to move. So we are able to walk because of friction. Okay, next, we can help to slow down an object with friction, right? Because we also don't want to end up moving all the time, right? We want to be able to slow down as and when we need it. So friction is the one that helps us to slow down when needed. Okay, that being said, it could also be a like negative effect of friction, right? So for example, cars, okay, especially the engines when they are running, the gears are able to will have to rub against each other, right? So it will generate friction, and as a result, cars are less efficient, okay, because of friction by up to 20%. Okay, then next, of course, the moving parts in engines will result in, because of friction, what will happen to them? Tools and machine, okay, suffer wear and tear. Okay, so this is the keyword for this part, wear and tear, less efficient. Then afterwards, okay, we need to talk about how can we enhance or reduce these effects of friction. So for example, since friction can cause wear and tear, right? How can we reduce this wear and tear? So we could use wheels, right? First of all, that's how cars even move in the first place, right? Imagine if the tires of the wheel or tires of our wheels, if it's not in a circular shape, right? Let's say if it's in a squarish shape, then it will have a lot of friction on the ground. So being circular in shape, right? Circular in shape helps to reduce friction between floor and object. So as a result, we use a less amount of force. Smaller force is used. Move object. Okay. Another effect. So if you look at skateboards, for example, right, in between their wheels, actually they will have okay this particular thing that's called the ball bearing. So basically, it's like wheels inside a set of wheels. Okay, so as the outside tire or sorry the wheels rotate, right, it will generate less amount of friction with this particular set of the skateboard. So these are called ball bearings. Okay, so another way to reduce is ball bearings. Okay, so also circular in shape, circular in shape, and reduce friction between moving parts of machine. Car and inline skates. Okay, so they are placed in between moving parts. Okay, next one, in terms of liquid, right? We could also use lubricants, right? One example of lubricants would be like oil, water, right? Typically, they are liquid, though there can be some solid lubricants, right? So for example, wax, that's one of them because it's slippery. Okay, so use lubricants uh, to reduce wear and tear. In uh, parts of the engine. Okay, now another thing is that we could also polish a surface. So if you look at the diagram just now, right, what happens if we actually foul off this portion of the surface, right, such that it's smooth, then there won't be the case of the resistance. I mean, a less amount of resistance will be faced, right? So polishing a surface removes surface irregularity, right? And helps to reduce the friction as well. So we have 4 points already. 1, 2, 3, 4. Okay, last one, we could also choose to use air cushion. Okay, so in between the surfaces, inject a layer of air. So friction between two surfaces are reduced with a layer of air. Okay, make sure you write them down. So for example, if I have a maglev train, right? If I have a maglev train, so imagine this was the train, right? Maglev just means magnetic, okay, and levitation, right? What happens is that the train will actually levitate above the track using the repulsion force of magnets, right? So there will be a layer of air in between, and this helps to reduce friction. Okay. Now that we talked about reducing negative effects of friction, let's talk about the positive effect and how can we enhance them. Okay. So it can be useful, right? Because let's say if I need to slow down a car, I will need friction in this case. Right? So positive effect of friction for cars, one of them is using treads. Now what are treads? Right? So if you look at the tire, right, if you were to look at the tire from the side view, you'll realize that there are layers of lines along the tire. Okay, now these are called the treads that helps to um, okay, as the tires spin, it will be able to grip onto the road better, right? As it helps to also eject out the water as the tire is rolling on the wet floor, for example. Okay, gripping onto the road. So using treads, right, enables the tire to grip onto the road surface without slipping. And that's how a car first is able to move, second is able to grip onto the road for control when it's trying to slow down. Next one, right? So let's say during a National Day observance, right? You will see these people that's called a red lion, right? And they will jump down the plane with this thing that's called a parachute, right? That looks like an umbrella, right? What happens is that with the air resistance is able to support the weight of the parachutist, right? To reduce the amount of resultant force on him so that he can land safely onto the ground, right? So these are called uh, making use of a type of friction, which is air resistance. So air resistance is a type of friction, right? So it will use the parachute. So let's say if he need to speed up or slow down, he can adjust his parachute. So by and large, for him to slow down, the parachute increases the air resistance, right? And how does he do that, right? What's the main point of the parachute? It's really just to increase the surface area, right? So that it can catch more air. In contact with the air. So again, the keyword here, increasing surface area, right? Increase the air distance. Okay, the first one, enable tire to grip onto road surface without slipping. Right, last one, to enhance the effect, which a lot of rock climbers will use this method, right? If I'm trying to climb onto the rock wall, I need to have a lot of grip, right, between my hand and the rock wall. So one of the methods is to use chalk. Rock climbers need to have a firm grip on rock surface with hands and feet. So for them to be able to do that, they use chalk to first absorb perspiration because it's water, so it could end up slipping, right? And improve their grip. Alright, so these again are the four um, three methods to improve or enhance the positive effect of friction. Right, and there you have it. Okay, let's move on to example 9. Now at any point in time, if it's too fast, please slow down, or if you think it's too slow, you may also speed up the video on YouTube. Okay, example 9, a force of 50 Newton is needed to keep a trolley of mass 60 kg moving at a uniform velocity of 2 meter per second. So again, if I have a trolley moving through a surface, right? So I need a 50 Newton push from the back, right? Why is there a need for the 50 Newton? So that there's a uniform velocity. Remember that uniform velocity tells me that it is zero resultant force. So resultant force equals to 0 Newton. That's what uniform velocity tells me. So that means that there's no resultant force. If 50 Newton is the driving force needed, the friction will have to be 50 Newton as well. Okay, so what is the frictional force? Since trolley is moving at uniform velocity, as the trolley has no resultant force according to which law would you want to use? Right, actually both of them are fine. So over here, I will actually say according to Newton's first law. Therefore, friction equals to 50 Newton. Right, now, second question. The effect of friction can be both positive and negative. Give one real world example for each. So again, it's just copying from here, right? Positive and negative effect from real world. So stating them, positive effect, okay, walking without slipping. Okay. moving object can slow down when needed. Okay, negative effect. What are some examples you can give? Okay, cars are less efficient by up to 20%. Second, okay, moving parts suffer from wear and tear. So wear and tear is actually a keyword. Alright, so these are the two answers, two questions. One way they can test you. Okay, and that is all. So all in all, we have covered, right, this topic on dynamics. Okay, tells us how it affects motion of object, right, and it's governed by three laws of motion. One is when it's balanced forces, that means no resultant force, how will it behave? Object can either continue state of rest or move in a uniform motion in a straight line, right? And if there is resultant force, then object will accelerate, or aka it will speed up or slow down, right? Third, Newton's third law tells us that forces occurs in pairs, right? How will one body exert a force onto another? So if I slap you, right, with my hand, my palm will also feel the same force, but in the opposite direction from your face. So this is called action-reaction pair, right? And that is all for this chapter.